Hello class. Today I'm going to teach you how to simulate a heatsink, a simple heatsink in Fluent, and hopefully you are going to use this training for your homework. I'm going to draw heatsink in SolidWorks because it's a little bit easier for me, and I'm much more familiar drawing complex geometry in SolidWorks than ANSYS. Part. Let's go to front view, make it normal, and draw it. About 5 centimeter or 50 millimeter, and 50 here. Okay. I know these are not very well designed. You need to have similar distances here, but you can do later. I'm just going to show you how to do it. Let's extrude it, and 50 millimeter is going to be enough. So it's kind of cube with 4 fins here. Let's save it. Save as heatsink. Okay, let's open ANSYS, double click on Fluent and geometry, because I already draw geometry in SolidWorks. So I'm going to right click, import geometry, and browse it, and select heatsink. As you can see, we have green tick here, which means we imported geometry. Let's double click mesh and open meshes. Okay. Let me see what is the default mesh. So right click on the mesh and generate mesh. Oh, so large. So I'm going to improve the quality a little bit by selecting relevance center as to fine, and hopefully it is going to be give me a little bit better. Okay, excellent. I'm happy with this quality. I know it's not enough, but let's accept. As you know, to make everything easier working with this geometries in the Fluent, we usually name different parts or important parts for us. For example, for this heatsink, I would like to put a heater at the bottom with a constant temperature, so I need to know the name or assign a name for this part. And for the rest, for all the other walls, I'm going to have convection. So let's put a name for the rest of the walls. Okay, this one is going to be easy. Click over it, right click, create name selection, and I'm going to call hot surface. So this is going to be my surface. Okay, and then I'm going to select all other parts because it is important for me to assign convection about these surfaces. I can start one by one by clicking Control button, which is going to take a little bit time, or right click, select all, and deselect the button. So now all the other parts are selected. Right click, create name selection, walls. So I have walls, everything except the bottom one, and hot surface. Okay, we're done with this one. Just let me check how many mesh I have. Okay, almost 50,000 nodes. I'm happy. Right click over mesh, update it to have green check there. Okay, double click on setup. We want to have double precision, parallel with 3, for example, processors. Okay, Fluent is loading the geometry. Yes, now the geometry is here. We want to have steady state simulation, so steady state is selected. Gravity is not important. Because we are going to have heat transfer, I need to turn on energy equation. So double click over energy and check energy equation. And laminar flow, that the rest is okay. For the material, the default solid is aluminum, and I want to just have solid. So the default aluminum is okay. Cell zones, which is this geometry, when I select part, it says automatically selected as a fluid, but I want to be solid, so I select a solid and aluminum. If I wanted to have other material, I could add materials there and select here. Okay, aluminum is the one I'm looking. Let's go for boundary conditions. Now you can see the names I put is going to help to assign their necessary boundaries. Hot surface, temperature, again say in Kelvin. Let's change the unit here, temperature to centigrade. So I'm going to 30 degree. So bottom is 35 degree. And walls, the surrounding for the fins everywhere, I would like to have convection, which is because it's a heat sink, it is going to convect heat from the bottom to the surrounding. Let's have, for example, this is heat transfer coefficient 500, and room temperature 26. I'm happy with that. I also would like to increase the temperature. Let's go with 40 degree, the bottom temperature. Okay, you don't need to change anything here. Let's go and initialize it. Initialize, it's successful. Now let's put 100 iteration. You can click here to check if it's anything wrong or you can improve. It says mesh, yeah, but we don't care about the quality of mesh for this. So let's calculate. Done. Calculation is finished. I'm closing it and I'm going to open solution. So results. Let's open results and see what type of heatsink we have here. Okay, you can see the heatsink geometry here. with counter. I would like to have counter for walls, and instead of density temperature, apply. Now you can see it starts from 31 degree, the coolest part, the blue part at the top, and hottest part is 40 degree, which we already know and we assigned there. Okay. Here I selected the location just walls, so it is going to show temperature profile just over walls. That is why we have just surroundings and walls. If you want to have just hot surface, select that one, and we are going to have hot surface, which is 40 degree, and it's a boundary condition, and we assign that temperature. If you want to have both, you need to select these three dots here and select hot surface and walls by clicking Control button and OK. Now if you apply, you are going to have all the surfaces we have here. Okay. Let's draw a line. Let me make it perpendicular to XY surface, location, line. Create a line. This is 0. X is going to be 0.01. And Y from 0 to 0.1. Let's see, where is it? So this is a line. The Y is too much. Yes, now it's good. Let's push it inside one of the fins, because I want to use this line and read the temperature over inside this fin, which is going to be interesting for us. Okay, now it's inside. Apply, and now it's time to draw a chart. Title is going to be temperature profile, and I would like the location be a line 1, which I just draw. X is going to be Y, and Y is going to be temperature. Let's apply. Yes. Now this is the temperature profile inside one of those fins, and you can see this is the 0 at the bottom for 40 degree. Gradually temperature decreases and reaches around 33, less than 33. Okay. So this is chart view, this is 3D view. And as you can see, the temperature profile at the left side and right side is not exactly same, because the sizes are different. I just draw without any accuracy, and the gap here is larger than the right side is larger than the left side. That is why we have a little bit temperature difference here, and you can see at the bottom side we have a higher temperature close to this area, and here, because this surface or button is closer to the hot surface, and between these gaps between the fins we have a air with convection, which we decided to have a 500 convective coefficient, so they are going to cool down here, but depends on the material we have. This is aluminum, so temperature gradient is going to be, if you select copper, you are going to have different temperature contour, and it is going to be very interesting to investigate. What about having different shapes or having holes on the sides to decrease the material? They are going to be again different. You are going to have different behavior. Okay, it's enough for today. See you next time.